In this lecture, we'll talk about story problems. This is the first example for story problems. This example says that three solutions contain a certain acid. The first one contains 10% acid. The second one contains 30%, and the third one contains 50%. Means half of them are acid. Okay? Yeah, this means only 30% of the amount is acid, and this one, the first one, tells us that only 10% of the solution is acid. We don't know the amount for the first, second, and third, so we may assume that's X, Y for the second, Z for the third one. Okay? Now, a chemist wishes to use all three solutions to obtain a 200-liter mixture containing 30% acid. So, among this 200-liter mixture solution, we want only 30% is acid. Now, if the chemist wants to use twice as much of the 50%, then twice as much of 50% solution as of the 30% solution, then how many liters of each solution should be used? Okay, right from here is that let's study with this one first. If the chemist wants to use twice as much of the 50%, 50% was what? Was the third one. Okay, so you want to mark the 50% is Z. Okay, so twice as much of the Z solution as of the Y solution. Okay, and you want to be sure right here is that which one is bigger by this sentence. This sentence basically tells us that the solution, the amount of solution for 50%, the amount from the third solution is actually bigger than the amount of the second solution. Okay, so you want to do is Z is actually greater than Y. Okay, that's the thing you want to figure out. Then you want to figure out where this twice should go. Okay, since Z is greater than Y, then you cannot double Z. You have to double Y to get Z. Okay, so that's why here I put a note. First, Z is greater than Y. Then you have to double Y to get Z. The popular mistake is to double Z get Y. That's wrong. Okay. Okay, this is what this sentence tells us. So we got this third equation. Now, the second sentence right here, a chemist wants to use all three solutions to obtain 200-liter mixture containing 30% acid. 200 mixture comes from the first one, X, comes from the second one, Y, comes from the third one, Z. So you have to add all X, Y, Z to get 200. That's one thing. On the other hand, we were told only 10% from X, the amount of X, is acid. So the acid, the amount from the first solution is 0.1 times X. because only 10% from the amount of x is the exit. 30% from the second solution is the exit. So 30% or 0.3 times y is the exit from the second solution. And then you see the third one is 50%. So 0.5 or 50% times the amount of the third solution, you'll get exit. Eventually, we'll get how many exit? Because the total amount of mixture is 200 liter. And our final answer is 30% exit. So out of 200 times 30% or 0.3, that would be the exit. That's 60. Okay? So if we get the equation, then you can get from the equation here, you can have a 1 times x, 1 times y, 1 times z. You have 1, 1, 1, 200. 0.1, 0.3, 0.5, 60. Because 200 times 0.3 is 60. That's the constant 10. Here z equals 2y. You minus 2y on both sides. You cancel this one. So the right-hand side is 0. So you put 0 here. And then 1 is the coefficient of z. So you put 1 here. Negative 2y. So negative 2 goes here. There is no x, 10 means 0 times x equals 0. So you put 0 here. This is the augmented matrix. Okay? Based on that, then you can do the rest of the operations. I'll leave to you, and I just list how did we get this equation. Okay? The system of the equation. The rest of them you probably want to enjoy yourself. Okay? All right. Now, let's look at the second example. The second example is that in electrical circuits, the formula 1OR equals 1OR1 plus 1OR2 is used to find the total resistance R if two resistors R1, R2 are connected in parallel. So the connection is showed up right here. R1, R2 connected in the parallel means in this way. Okay, the electricity goes here, and then they go R1, R2, okay, and then comes out from here. And then from here to here, what is the resistance from here to here? Okay, so that's R. That's R. The relationship among R, R1, R2 is given in this way. This is given in physics. Okay, so you don't need to know why in mathematics. If you know in physics, you can test to make some experiment to find out. Here, we were told this is the relationship. Okay, R1 from here, R2 from here. R is the total resistance. Okay. All right. Now, given three resistors A, B, C, suppose that the total resistance is 240 ohms if A and B are connected in parallel. So if here instead of R1, R2 is A and B, then we get 240. So 240 RA, RB downstairs is right from here. Okay? And then we will get 300 ohms if B and C connected. So B and C are connected in this way. B, C. this would be R. Total resistance would be R. And then here, the last one says that we have 400 ohms if A and C are connected. Okay, RA, RC. And the total resistance will be 400. Now here the trick is that to solve this one, you want to let X be 1 over RA, so this place can be replaced by X. You want Y be 1 over RB, so those two places will be Y. And you want Z be 1 over RC, so these two places will be Z. Okay, you keep rest of them. And then you can see X, Y, no Z, so coefficient of Z is 0. Then you write X is again 1 times X. Y is again 1 times Y. So you have a 1, 1, 0, and then the constant right here, 1 over 240. This one is the similar token. No X means 0 times X. 0, 1, 1, 0, 1, 1. Constant is 1 over 300. XZ means 1x plus 0y plus 1 times z. Because again, x is 1 times x, 0 times y is 0, and 1 times z is z. So 1, 0, 1, 1, 0, 1, and then constant 1 over 400. After you get augmented matrix, then the rest of the way things is to solve it. Okay, I have written the answer right here. You probably want to go through that yourself. Okay, and here is just I want to show you how to get this equation and some little trick right here. 1 over RA, 1 over RA is X, 1 over RB is Y, and 1 over RC is Z. And then we got augmented matrix. Eventually we can find out the solution by using back substitution. There are details right here. Please read yourself. So we have done 2 examples right here. Hope this will help you to do the assignment. I'll see you next time.